Welcome to the next installment of our lecture on statistics. This time, I will talk about two different types of statistics, the descriptive statistics and the inferential statistics. So first, we will have summary measures or our descriptive statistics. Summary measures or descriptive statistics is a measure of central tendency and variations. These are values that attempts to describe a set of data by identifying, for example, the central position within the set of data. As such, we call it central tendency or summary statistics, which involve our mean, mode, and median. While variations, on the other hand, is another way to summarize data in terms of dispersion or in terms of differences from each other. Now let's proceed with central tendency summary measures. Our central tendency refers to the middle of distribution. It is a descriptive summary of a dataset through a single value that reflects the center of the data distribution. Under central tendency, we have mean, median, and mode. Mean or arithmetic mean means our average. This is the most popular and well-known measure of central tendency. It can be used with both discrete and continuous data, although it is used most often with continuous data. The mean is equal to the sum of all values in the data set divided by the number of values in the data set, in short, the average. An important property of the mean is that it includes every value in our data set as part of our calculation. In addition, the mean is the only measure of central tendency where the sum of the deviation of each value from the mean is always 0. But our mean has also a disadvantage. It particularly is susceptible to the influence of outliers. So these are values, outliers are values that are unusual compared to the rest of the data set by being especially small or large in numerical amount. For example, consider the general or the common answers in our data set here lies from 13 to 18. So our 21 here, or if we have a value of more than 21, that can be considered as an outlier. The, the outlier can be addressed if we inspect the raw data and we can see right away for differences or for peculiar items. If you can inspect your data and you can check for outliers, you can have a better measure of central tendency. The next central tendency is the median. The median is the middle score for a set of data that has been arranged in order of magnitude. The median is less affected by our outliers and skewed data. So if our set of data is odd number, like the one in our picture, we have 5 items, so we can easily see where is the median, which is 5. But if as we arrange our data and we have even number like 6, so we have 2 median here, so we will take the average of our 2 median, which is 5 plus 7 divided by 2. Now our median is 6. The next central tendency is mode. The mode is the most frequent score in our data set. On a histogram, it represents the highest bar in a bar chart or histogram. So we can therefore sometimes consider the mode as the being the most popular option. Normally, the mode is used for categorical data where we wish to know which is the most common category. However, one of the problems with the mode is that it is not unique. So it leaves us with problems when we have two or more values that share the highest frequency. So we will be stuck as to which mode best describes our central tendency if we will get or we will have two modes. This is particularly problematic when we have continuous data because you are more likely not to have any one value that is more frequent than the other. So for example, consider we will measure 30 people's weight to the nearest zero point 0.1 kilogram. How likely is it that we will find two or more people with exactly the same weight? For example, a weight of 67.4 kilogram. So it is very unlikely that we will have the exact 67.4. So many of our 30 respondents may be close to that 67.4, but with such a small sample and a target or on a large range of possible weights, we can have or we can just find at least two with the exact weight. So it is not very useful to use mode for central tendency measure or summary measure if our data is a continuous data. So when it is best to use our central tendency? So if our variable is a nominal type, it is best to use mode. If our variable is an ordinal, we can use median. So if our variable is interval or a ratio and is not skewed, the distribution is equal, then we can use mean. Then followed by, if our interval or our ratio is skewed, we can use median. Now for the next summary of measure, we will talk about variations. So variation, we can have here range, variance, and standard deviation. Variation or variability, it refers to how spread out a group of score is. So these graphs here will show us the different variability of data that we can gather from our research instrument. Despite there is equality of means, we can still see the distributions are quite different, specifically if it's spread out or dense packed. If it's dense packed, there will be low to medium variability, and if it is spread out, it means higher variability. So let's talk about range. A range is one of the most basic measures of variation. The range is the simplest measure of variability to calculate, and one you have probably encountered many times in your life. So range is the difference between the smallest data in the item or data set and the largest. So for example, the smallest is 73 and the highest is 94 in your grades. So that is 94 minus 73, so the range is 21. Now let's have variance. So our variance is the one that can tell us how far our data is spread out. So it is an abstract number that really is only useful for calculating standard deviation. So our standard deviation and our variance can be classified if our data set is from a population or from a sample. Now standard deviation is simply the square root of the variance. This makes the standard deviations very useful to help us identify if our data set is near with each other or far from each other. So if our standard deviation is equals to 1, we have an average deviation. But if it's more than 1, there is large deviation, meaning our results are far from each other. And if our standard deviation is less than 1, nearest to 0, that means our results are very close to each other. The numerical values are close to each other. So this is a picture of our range, average, mean in terms of the variations. So we have here different data sets that can help us understand more the summary measures on variation. So our central tendency measures also relies with our distribution or the how data is distributed in the population. So why are measures of our distribution shape useful? The shape of the distribution can assist us with identifying our descriptive statistics, such as which measure of central tendency is appropriate to use. If data are skewed, the median may be more appropriate measure of central tendency. So, non-symmetrical and skewed have different demands for descriptive statistics. So we have left skewed, symmetric, and right skewed. So if our distribution of data is left skewed, it's better. That means our mean is less than median. And if it's right skewed, our median is less than our mean. So for skewed item or skewed data distribution, we should use median in our descriptive statistics. Now for symmetric, which is median and mean are equal, that means we will use mean or average for our data summary measures.